We're now going to be looking at graphing quadratics. Remember, quadratics are the U-shaped, a parabola, parabolic, trinomials. They're things with an x squared. We graphed them in the previous chapter, I think, where we had to find a vertex, find a couple x-intercepts, find a y-intercept, and then connect the dots. And it was a very long process. So now what we're going to do is we're going to learn a pattern, a way of doing this, and it's going to start with the vertex, and it will easily draw the rest of this. However, it won't find the x-intercepts or the y-intercepts. Sometimes it might by accident. So if we're ever asked to find the x and y-intercepts, we still have to do the method from the previous chapter. But this method will work for just graphing it. Now, when we graphed lines, which is how we started this whole thing, was a review, you started with the y-intercept, and then there was some sort of slope, some sort of pattern, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And sometimes that pattern changed depending on what the slope was. We're going to have a new pattern. So we're going to do a couple of examples, and by the end of this, you should and at the end of these 4 questions, you should have a really good understanding of how to graph these and what the patterns are. First thing you always need to do is you need to start with the vertex. So vertex, remember a vertex has an x and y coordinate. The x one is right here, but it's the one beside the x. However, apparently I can't highlight. However, it is not the same symbol. So it says -1 there. We're going to do a +1. And then the y is off to the side there. It's a -4. We stay -4. So you change on the inside. You don't change on the outside. That's our vertex. So 1, -4. So that's where we are. Now, so far, that's not a pattern. That's just finding the vertex. Now, the pattern comes from creating a little chart. Now, there's different ways to teach this. I've taught it with this chart. I call it a over, up, down chart. Very much like we had rise, over, run. And for linear equations or lines. Now, it's always going to be like this. 1, 1, 1. And this side will always be 1, 3, 5. Now, I did mention before that whatever numbers out in front indicates whether we head up or down. So if it's a positive number, we head up. If it's a negative number, we head down. There is no number written there. That's because it's a 1, a positive 1. So if it's a positive 1, that means we're going to be heading up. Now, you always will create this chart every single time. And it's so easy to remember 1, 1, 1, 1, 3, 5. It actually keeps going 1, 7, 1, 9, 1, 11. So you can see the pattern there. It's always 1, and then it always goes up by the odd numbers. We usually don't go past 5. Sometimes I go to 7, but I usually stop there. What you need to do now is this up-down chart, which is an up for us. You have to times this number by whatever number is, these numbers, by whatever number is out in front. There is a 1 out in front. And so I need to times it by 1, which is useless because anything times by 1 is itself. So it's 1, 1, 1, and then 1, 3, 5. So from this graph, from the vertex, and because we're heading up, go over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. So again, you start at the middle, go over 1, up 1. From there, go over 1, up 3. From there, go over 1, up 5. And then do that to the other side. Over 1, up 1. Over 1, up 3. Over 1, up 1, 2, 3, 4, 5. So we have this graph at the end. And lucky for us, it actually did find the x-intercepts. The x-intercept is 3 and -1, and we do have a y-intercept of -3. It was able to find them just by accident. They happened to land there. So that was kind of nice, but it wasn't expected. There is some symmetry. That's how we can do this. So there's a symmetry. There's a symmetrical line right here. where this half flips over and matches that half perfectly. And so that's why we can do to one side over 1 up 1 over 1 up 3 over 1 up 5, and the other side is identical over 1 up 1 over 1 up 3 over 1 up 5. This is called an axis of symmetry. So we have an axis of symmetry when x is 1. Now, that's it for graphing. And I realized that this video was like 5 minutes long. So I'm going to do a new video where we can very quickly go through B, C, and D.